Hi, this is Evan with AutoNMS, and I'm here to bring you another Rave short. So today we have a simple network that I created for the whiteboard to demonstrate some features that are new in the whiteboard. So now we have the ability to add custom links and custom clouds to external networks on the whiteboard. So we can just right-click on a node and say add link to. We can create a cloud to custom cloud environment. So we're going to say customer V, and it'll ask you which interface you want to connect this cloud onto. So we're going to say Ethernet 2, and then the cloud will be added to that environment. You can also add custom notes onto this, and you can use this field to reference notes for Rave to ingest. So if you learn about a certain route from this customer environment, then you can ask Rave to tell you about the routes coming from that environment. And you can also add the clouds to multiple different links as well. So we're going to just put 8.8.8.8 learn from this customer. So we can just put that there. And then you can also right click on the cloud and you can create another you can create another link to a different node. So we're going to say that we want to create a link to the Cisco node. And it's going to ask you which interface we've got this one connected to use. So we're going to say Ethernet 03. And as soon as you do that, then it'll draw a secondary line to Ethernet 03. And we will come back to the different interface types that you can use here. So we have obviously the legacy subnet highlighting containers the /30s that are in use. You can also choose to turn on the management interfaces, or you can also turn off the management interface and the external clouds as well. So that feature is there. Another one of the main features that I brought in here now is that there's an expandable Rave button that'll give you different options for the Rave panel that are now available. So we have the obviously the Rave Engineer and the Rave Dashboard, which are existing that you have already seen before. A new module that I created is called the Rave Vocabulary module, which is right here. This allows you to customize and speak to Rave in a way that she'll understand what you're talking about. So if you refer to a certain part of your network as a certain type, or if you refer to your core switches as a certain name, you can input the synonym that you use and relate it to a certain word, and then she'll be able to figure out what you're talking about just based on this intent. This is similar to the types of fields that are available underneath the nodes in the management category. So you specify who owns a node, where the node is located, which UPS is plugged into, which power feeds is plugged into, and you can use all these fields to interact with Rave. So you can ask Rave about specific things. So, for example, this particular node is owned by Dave Jones and it's in Denver. But if we come back down to this node right here, we'll say that this node is in Miami. And then when we go to we'll push save notes, and we'll go over to the whiteboard and we'll say to Rave, we'll just bring it up here.
Hi, I'm Rave. Just speak in natural language about your AutoNMS network and I'll help you figure out the details.
Say to Rave, how does Denver reach Miami? So we'll just ask her that. And she answered right away, but text to speech is obviously a little bit delayed.
Cisco reaches left via EOS 1.1.1.1 via Cisco to left via EOS.
And she actually lists
Hop by hop 1. Cisco to left via EOS. Next hop 10.0.12.1. Matched 1.1.1.1/32 via OSPF. This is the path traffic is actually taking. Every hop is read from that router's installed forwarding table the routes it has selected and is forwarding on, resolved by longest prefix match, the same decision the hardware makes. It's not a topology guess.
Okay, and you can go into the routing, obviously, if you're a little bit more inquisitive on that, and you could figure out, you can just click on a different node and it'll bring up the routing table for that particular node and figure out how it's reaching certain prefixes, and you figure out which path is actually taken through the network. We also have um, a few other features that are new, and the new Rave design module, which I'm not ready to demo that yet, but basically the Rave engineer is um, on the level of being able to perform brownfield network topology scanning as well as most human engineers right now. So she can evaluate and answer questions about futuristic predictions. She can give you information about your network that is currently observed through historical discoveries right now. But the Rave design module, which I'm going to be releasing in a couple of days here, is all about greenfield deployments. So places where your network has never existed before, using best practices and things of that nature in order to generate configurations for devices that have never existed before. So we'll just ask Ray a few different questions here just to kind of summarize the video here. So we'll say, what happens if say hop count the hop count between two nodes. So we'll say the left VOS to the right VEOS. And obviously you can see on the diagram here, this is a pretty simple topology, but we're traversing the Cisco node. So we'll just push ask Rave.
Left VEOS has no route to right VEOS 4.4.4.4 in its installed forwarding table. Either they genuinely can't reach each other, or AutoNMS hasn't captured left VEOS's routing table yet.
So that's unexpected, but I'll go with it for right now. And let's see, we'll ask for one more question. We'll say uh, uptime across the network, or actually the node health. We'll ask her about how the Cisco node is doing. And she answered right away, but text speech is taking longer.
Cisco looks healthy, 5 interfaces up, 0 down, 0 recent errors, 0 recent drops.
And we'll ask her that final question having to do with uptime across the network.
Uptime across 3 devices. Cisco has been up longest at 8 hours. 3 devices have been up less than a day, which usually means a recent reboot.
So it should be pretty evident at this point that that Rave is the future of network engineering. She can answer questions. She can do futuristic predictions. For example, I think I've demoed this one before, but you could ask her what would happen if the Cisco node disappeared, for example. So she's able to evaluate the OSPF LSAs and figure out what would happen if it was not
Cisco
there.
192.168.54.241 disappeared. Routing impact analysis. OSPF. Recomputing shortest paths with Cisco removed. One router become unreachable from left VEOS right VEOS. Genuine partition. Cisco is the OSPF designated router for 2 segments. Losing it forces DR reelection, and those segments reroute via point-to-point links. BGP. 2 IBGP paths are currently RIB failures. The IGP EIGRP/OSPF owns those prefixes, so BGP is a backup layer, not the active one. Losing Cisco only affects BGP reachability if it also removes the IGP route to a BGP next hop loopback.
So she's obviously pretty adept at delivering answers that can more closely relate to your network. She's self-learning. She does not require tokens or credits of any kind. She has no usage limits. She can't hallucinate because of how she was designed. Um, every feature that is available on typical NMS is available inside here. So, we've got the ability to basically categorize every single device precisely in a way that Rave can use to determine how your particular network is configured and designed. And if you have any questions, please go ahead and direct them to me. I'd love to help you integrate Rave into your network. Have a good day. Goodbye.